Hey guys, welcome back. So today we're going to be doing a work example. Question number 5, the one I've just highlighted. Pause the video now if you want to try it yourself and come back for the solution. Alright, so I assume you're done, so let's switch over to the whiteboard. The first thing I think is a good step whenever you do these types of questions, these um, Hess's law questions that involve the algebraic manipulation of stuff, write down your final end goal reaction up top, or up front and center. So in this case, it would be 1C6H4OH 2 plus H2O2. I'm forgetting my states. Yields, in this case, C6H4O2, which is aqueous plus 2 waters. Now, our first reaction is C6H4OH2 decomposes C6H4H2 gas. The second one is, then I'll center them. The second one is H2 plus O2 yields H. Our third one is and then our last one is that. Now, first, let me just center everything so it's a little bit clear what it is I'm going to be doing. I'm going to center everything a little bit. So, yeah, there we go. So, now I look at each individual equation and see what I have to change. So, for the first one, this looks to be good, so that's fine. The second one here, the H2O2 is on the reactant side, whereas here it's on the product side. So therefore I want to flip the reaction, and because of how Hess's law works, when I flip the reaction, I flip the sign on delta H. So let me just flip the reaction. Actually, what might be better is just to do it like this. So if I flip that, I flip the sign. So I took care of the flipped sign by just noting a negative there, just so I remember to flip the sign. For the third one, it looks like um, hmm, does it look like I want to double it? Yeah, it looks like I want to double it just so I can get rid of those H2s there. So for the third one, I'm trying to cancel out the oxygens, and the way I do that, it looks like I'll have to double it. So I'll but if I double it, then oh no wait, no, doubling it works. So I want to double that. So if I put a 2, if I put a 2, and then if I put a 2 and a 2 and I double all the things, I'll get a 1 there. And then for the last one, there's 2 gaseous molecules, so I want to double this as well. So 2 and then 2. And then now we add up all the reactions together to make sure we get what we want. So in this case, this H2 and this H2 cancel with those H2s. Remember, I'm canceling things that appear on both the products and the reactant side. This oxygen here cancels, and these two gaseous waters cancel out, and I do in fact get C6H4 OH2 plus H2O2 yields C6H4O2 plus 2H2O. So what I did there is that I manipulated my equations to try and make sure that when I add them all together, the net result is the one that the question asks for. And then I made a note of how I manipulated them so that I remember that, so I remember how to add up our delta H's. So remember that, so remember to make a note of how you're manipulating your stuff, so that when you go to add everything, it's easy to do the adding because you know how you manipulate your numbers. So for the first one, the delta H was 177.4, and then I have to remember to add negative 192, negative 191.2, so that would be 191.2. So let me just write this out here actually. So our net sort of okay, I just needed to make sure I could find my mouse. Okay, so our net reaction would be 177.4 plus negative 191.2 plus 2 times negative 241.8 plus 2 negative 43.8. So when I do that, in my calculator, plus 2 plus 2, I get that the delta H equals negative 202.6 kilojoules. And that's our answer. Thank you very much for watching. Don't forget to like and subscribe.